going to be. All right. So we were talking about the Hamilton Standard Hydromatic yesterday, and I had this point, the hub assembly, and what were the points in the hub assembly. And in proof that Hannah has stolen all of my notes, she was able to name every single one of these things in the order listed, proving that she's cheating. I could accuse her of being smart, but it was. So we have the spider, we got the blades, we got the blade gear segments. We had the barrel halves. We had the necessary support blocks. We had some spacers and the bearings. And the other major part was the dome assembly, and that's the part that's going to sit out front. I was going to say on top, but and inside this dome assembly, we have various parts in here. Hannah, do you want to guess them all in order again?
Sure.
All right, go for it.
Piston and stationary rotating cam.
Let's see. I have 1, 2, 3, 4, 5, 6 items. And what did you give me?
Piston.
Piston. Okay, what else?
Rotating cylinder.
Rotating cylinder. How about rotating cam? Rotating cam cylinder. What else?
Stationary cam.
Ooh, stationary. Pitch stop rings. Got the pitch changing mechanism. And the dome shell, also called the cylinder. What? The planet? I don't have that. Let's see. I want to change this up just a little bit. So as I said yesterday, this particular propeller, not only does it work different than everything we've really talked about so far, but I've noticed that there are several versions of this propeller and how they work. So you could actually get another version that's going to work different than this one. And when I'm looking at your Q&A questions and I'm trying to figure out, okay, which one should we talk about? It really doesn't matter because most of your Q&A questions and what you really seem to have to know most about this is how the feathering mechanism works because it works so different. But we'll kind of go over the basic operation of it. In the slides that I have right now, this is using what's called a double acting governor. And I think the reason why I probably picked this one, because these two guys crack me up, and because it's an introduction to a double acting governor. So before we talk about this, I will say that, and I think the book that I've given you guys in Canvas, the way it talks about the operation is, number one, it references inboard and outboard. So this would be the inboard and this would be the outboard out here. And on one side, the outboard, you will always have engine oil pressure. And so you always have engine oil pressure. So notice there's no springs, There's no air pressure. There's no counterweights at all on here. And so what do we got? An underspeed, and it's trying to move it this way. So underspeed goes to high pitch. Okay, so low pitch, so I'll make sure I have this right. So low pitch is going to have what for the fixed force? To go to low pitch. It's always got centrifugal twisting force, right? Got to find it. So it's got centrifugal twisting force, and the other fixed thing now is?
Engine oil pressure.
Engine oil pressure. So there's your fixed forces. So you always have that working. So anytime you're going to lose what's behind the piston or the inboard section of the piston, anytime you drain this off, the propeller is going to go to low pitch. All right. So, and here we've got an underspeed condition. So underspeed condition, I hope I said all that right. Let's see. Underspeed, the condition results. And also, I will say this, I've noticed that it works backwards sometimes. So I've seen some books describe this action where one way is doing one thing and one is another. But anyway, so there's the way I just talked about. Then there's what's going on here with this double acting. So in this double acting, this condition, so we have an underspeed. So here's, what do we have here? Our flyweights. How's the situation, Gov? Because it's governor, right? Things are on the decrease. All right, this condition results when the plane starts to climb. So we have an underspeed condition. So what needs to happen? Well, we have engine oil pressure coming in through here, going through the governor gears, and as soon as it goes through, it becomes high pressure. So high pressure is going to roll through here, and you see little arrows. It's going to come through here and push the piston forward. The piston goes forward, and that is going to go into low pitch. All right. In this one, we've got an overspeed condition. So now before we drained oil, right, off all the other props. So this time we have high pressure oil coming through. It's going through the gears again. But this time, because the pilot valve has changed, it actually is just going to redirect to the front. So now we've got governor pressure on the front of the dome or the outboard side. You follow? It's very different, right? So otherwise, it's not a whole lot different, but if you understand the other concepts, then you're great. Now, of course, you also had to open up a passage here to drain off oil. If you didn't drain off oil, then what happens? Yeah, you got a hydraulic lock in there, so that didn't work so well. So going back here, it opened up this passageway so oil can come through this way, and it goes back to the inlet side of the pump or whatever's not being, so it just drains off the inlet side of the pump. So underspeed, overspeed, and what's my other one? On speed. Well, nothing's changed here. We still have the same thing going on. So we have the engine oil coming through here, going through the pump. Can't go anywhere, so what does it have to do? Relief valve right there. So there's our pressure relief valve, and we'll circulate. So how's it going, Gov? Steady it goes. There we go.
Did you write that yourself?
I know. Does that look like I did that?
Handwriting, no, but you would totally say handwriting.
I would have to get Hannah to make the little drawing for me. And then all right, so I don't want to spend a lot of time talking about that because I think you guys kind of get it. But here's where I do want to spend a little bit more time, is how this feathering system works. So how did we feather all the other props now? I want to feather a prop. What's the procedure? Not this one, but the Macaulay, the Hartzell, or Herzl. If you're,
lever all the way.
okay, bring the prop levers all the way back. Do they just slide all the way back? No.
Sometimes they do.
Not supposed to. I get to a point, a what? A detent. So it's something that stops the pilot from just inadvertently going all the way to feather. Well, why would that be a bad idea if you go all the way to feather when you're just trying to reduce the RPM? Yeah, well, you get thrust, it's just going the wrong way. So instead of the propeller pulling you through the air, it pushes you go the other way. All right, and so sometimes these detents will actually have a pin that will lock it. You can't physically in flight bring these handles back. So what's going to release that pin that would allow you to, I'm sorry, I was thinking beta range. I take that back. So no, erase, delete. All right, so there's no pin on the feather. You don't want you to feather in flight. That's what I realized. What the hell are you talking about? All right, so there's a detent, and you don't want to inadvertently just go to feather. So anyway, sometimes you have to lift them up. The prop handles, you shouldn't do them both at the same time, I would imagine. Lift it up and back, or move it to the side a little bit. But anyway, something's just going to make it a little more difficult, so you just don't inadvertently go. All right, and so I do that. What's happening with the system that makes it go into feather?
It's releasing all the oil out of the.
I hear a lot of silence. Do I need my little...
Isn't it pulling the pilot valve?
There you go. Pulls the pilot valve all the way up. Okay, then what happens? Drains all the oil out of the prop.
The centrifugal force and counterweight through.
Centrifugal force from the counterweights, and usually spring and or air pressure is going to drive it to feather. And to get it out of feather, I simply, well, it's one of two ways. Okay, so who said accumulator? There you go. So if I have an accumulator, I just bring the prop handle forward, and it releases the oil that was stored in the accumulator into the prop to bring it to a lower pitch, which then starts it windmilling, which would then start the engine. What if I don't have an accumulator?
It's the starter.
Hit the starter.
Bring the propeller also out of the.
Bring the propeller out of feather, hit the starter, and as the starter is motoring the engine over, you're going to build up oil pressure to bring it to a lower pitch and start the engine. All right, the system here in the Hamilton Standard is completely different. And so what you have, instead of having it attached to the prop lever, there's an independent button, big old button, about 1.5 inches on the instrument panel. It says feather. You push it to feather. And so I guess I'll tell you the story now. So I know somebody who had purchased a Twin Beach, and that one right there, a picture of that, and was out on his check rides. Had a good friend of his who flew freight and knew these planes very well, and they're flying along and everything went great. And he said, I feel like I really should maybe put an engine away, feather it, see what it feels like with single engine, and then when I get the feel of that, we'll bring the engine back. So, it's a good idea. So I hit the feathering button. Prop goes into feather, shut the engine down, fly it around, get the feel for it. All right, that feels pretty good. I'm ready for lunch. You ready for lunch? Ready for lunch. Okay, go and unfeather it. I don't see an unfeather button. You know what to do? I don't know what to do. I knew what to do. So I just declared an emergency and landed on single engine. So, and then read the manual and then, all right. And I feel bad because right in the middle of him telling the story to all of us, I go, all you have to do was, and he's like, well, I know that now. Don't be a jerk. All right, so where do we begin here? So, all right, so to feather it, the pilot or co-pilot or, whoever, passenger, I don't care, is going to push in this giant button. When you push in this button, it is going to go through wires, and inside of here, well, it says holding coil. It's exactly what happens. There's a big coil in here that it's just, you're going to energize it. I never really followed this around. You're going to energize a magnet in there, and that magnet's what a holding coil is. So you push the button in, the magnet is going to suddenly turn on and hold the button in. So the button stays in, and then you're going to go back to a relay back here. Well, a relay is just an electrical remote, if you remember. So it's a way to use little tiny wires, and this is nice because the black represents little tiny wires. So little tiny wires to come in here and activate this magnet, which pulls this bar back against these two contacts. All right, that allows this big fat wire to come up through here and energize this electric motor. And I will just point out that this had better also be a big fat wire or that wire will melt. But anyway, that's not neither here nor there. So, bad drawing. So that starts the motor. Well, when this happens, it is going to come up here, cut out the governor. So the governor is taken out of the picture. No more governor. And this pump is going, and it's going to line it up. So this pump is going to pump oil from an oil tank through the pump, hit the switch, and it's going to go up to about 650 psi and drive that propeller to feather. And then once that propeller hits the stops, this pump doesn't know any better. It's just going to keep going. And it's going to start driving that. Well, it doesn't quite get up to 650 at first, I should say. It will go up to 650. But as it starts building up this pressure, when the prop stops, it's against the stops, it can't go anymore. The pump just keeps going. And there's a pressure switch in here. Oh, there it is. Pressure switch in here. And when this pressure switch gets to about 650 psi, it's going to say, the prop is either on feather right now or it's not going at this point. So it opens up, and when it does that, it opens up the wire that releases the holding coil and releases the solenoid. Boom, everything shuts off. The button pops out on its own and the pump shuts off. And the prop's at feather. Make sense so far? Okay, so that's what my friend did. And by the way, inside of this oil tank, it's kind of designed in such a way that it it has a pipe in there, and this would be 2-engine. And so if the oil level gets to right here, guess what happens to the oil going to the engine? You see that?
You don't.
What happens to the oil going to the engine?
You don't have
You don't have
any.
any. You only have enough left to do what? To feather the prop. So there's a little pipe in there is lower than that one. So standpipe up, this one down, so that the feathering pump is always going to get the last little bit of oil. So if you blew a hose, lost all your oil, engine's oil pressure drops to nothing. You look at, whoa, engine is out of oil, and I'm thinking of Madagascar. Sir, we're out of fuel. We're out of oil. Why do you say that? Engine 1 is no longer on fire. All right, so enough of that. So anyway, the last little bit of oil goes to the feathering pump. All right, so we've got it in feather. And how do you unfeather it? Well, there is no unfeathering button, but the feather button is the unfeather button. So you take this feather button and you push it in. Now, if I push the feather button in at this point, I push it in, what's going to happen? Push it in and let go. Well, why is it going to pop back out? Because it will. I push it in.
Because once the pump kicks over, it already senses that it's at too high of a pressure.
That's exactly what's going to happen. I push this in. We're going to go through the sequence again. The holding coil is going to activate. It's going to close this solenoid. It's going to turn on the pump. The pump's going to go. It's going to get a few rotations out of it and go, whoa, we're at 650 psi. You better stop. Click, bang, feathering button pops out. All right, but if I take that feathering button and push it in and hold it, force it in, then what's going to happen is the holding coil will say, no, it's not going to work. It's going to try and release this, but you're sitting there with your foot on it or hand on it, and foot on it in case you have a soda or beer in your hand. And that's going to force the pump to keep going. And if the pump, as it's forced to keep going, what's going to happen is there is I don't think I have a picture of it. No, I don't. And I just locked myself out until this decides. All right. And there is a valve assembly in here. And when that pressure gets over 650 psi, it's going to realign these valves. And so it's actually going to open up a passageway that is going to reverse the oil. So before, it's putting on one side of the piston, but once I go above that 650, it's going to realign the valve and send the oil to the other side of the piston, which will then make the blades start to go into a low pitch. And as soon as the blades start to go into low pitch, what's it going to start doing? Windmilling and rotating. Once it starts doing that, let off the button, oil pressure will pick up and it will go just like normal. Did you follow that?
Mm-hmm.
I hope so.
So, is it button?
Basically, if you wanted to get it out of feathering this system, you just hold the feather button down.
You just hold the feather button now. That's all you got to do.
But you use same cylinder, right? For the same as governor.
Same cylinder, same governor?
Yes.
Yeah. As the one, well, not all governors are the same, but there's nothing special about the governor unless it's the double acting governor that I talked about, but it doesn't have to be. But it's got to be set up for the prop. But otherwise, no, there's nothing special because it's the distributor valve that's going to change, and the distributor valve is part of the propeller assembly, not the governor. don't think I have the distributor valve. I do not. Well, I should have that. All right, so we have the dome assembly. I had my notes. I'll just put this so I don't get too messed up, but low pitch. Stop lever. Assembly. All right, then we have the governor. Now again, the governor can be a single acting or a double acting. So I'll just put that. Can be single or double acting. Anybody not clear on the difference? Single acting is what you studied in lab. It's what we've been talking about all the other props. Double acting is the one that can reverse the passage of oil. So it can send high pressure oil to the front of the dome or the back of the dome. We'll just skip to this. There's a feathering system. One uses a push button rather than a lever. Push button. Rather than a lever. To feather and unfeather. All right, so the sequence, when the button is pressed, a holding coil holds the button. In until the feathering operation is complete. So when button is pressed, a holding coil holds the button in until the feathering operation is complete. The button energizes a solenoid to an electric motor. Energizes a solenoid or relay. I'd rather call it a relay, I think, to an electric motor. That drives a pump to supply 600 psi to the prop. Oil for feathering is supplied from the engine supply. Yeah?
Why doesn't it have its own supply?
Well, that reminds me of something else I was going to talk about. It's just as easy to take it from the big oil sump. These things have huge oil sumps for these radials. So one less thing you have to do. By the way, we were talking yesterday, if you remember, about why doesn't a single, I'm going to hate myself for this, why doesn't the single engine prop operate the same way as a twin engine? In other words, why doesn't it have counterweights and default to, anyway, why doesn't it have counterweights? And Juan actually made a bunch of phone calls, several, to Macaulay and Hartzell. And the answer that most places gave him was, I don't know.
Simplicity, costs.
Yeah, but first you got a whole bunch of I don't knows, right?
Oh, first, yeah.
Yeah.
So like gas in the oils.
Yeah, I don't know. But finally got some guy on the phone. Oh, simple. Simplicity, cost, weight.
That's kind of what we came up with.
That's right. So look how smart we are. We didn't need to ask them. All right. High pressure from the feathering pump. High pressure from the feathering pump. Shifts the transfer valve in the governor. Shifts the transfer valve in the governor to hydraulically remove the governor. So we don't want that governor anymore. We want to get rid of it. It's going to mess things up.
Kevin,
Yep.
the question why the high feathering boost pump doesn't have the extra, its own kind of oil supply, I think it is because once you reverse that process, all the oil actually returns back to the engine.
That's a really good point.
So-
You could do it once or twice.
Exactly, so you could do it only once, and then you would, every time you would have to refill.
Excellent point.
I think another point is how often do you actually feather the prop so the oil could go bad and it loses viscosity?
Okay, I like that one. You guys walk by the Hydromatic that I let Tom run for you guys and notice the big red light on? It's a heater. So it doesn't even, I believe it didn't even work the first few times he tried it after he plugged it in. I mean, it'd been sitting for a year and he plugged it in and tried it. He didn't want to move at all. The oil was really thick in there. I'm surprised at that, actually. I would have thought it would have worked. But anyway, it's, yeah. So we could have freezing problems, cold oil. So see what you started?
My answer.
I know. Let's see. The high pressure is then diverted to the piston to drive the blades to feather. And when the piston stops moving, the pressure builds. The pressure builds to over 600 psi. And at 650 psi, or thereabouts, let's see, 655 psi, it will trip a pressure cutout. Trip the pressure cutout. Shutting off the motor. The blades are held in feather by aerodynamic forces. All right, there we go. Yes.
On the pressure cutout,
Uh-huh.
does that have to be checked pretty often?
Oh, no, never worked on this system. I would venture to say yes, everything in an airplane is checked every so often.
Like pretty often, like more often, because if it's holding in 600 psi.
Wouldn't it be more prone to that?
Wouldn't it be for like a 100-hour renewal or something like that?
Probably. Sorry, I do not know the interval of check. I would assume that it's checked every year, at least every year. But as far as do you have to put a pressure gauge in, verify the pressure, adjust it? I don't know. Probably not. Don't know. Unfeather. All right, how do you unfeather it?
Hold the button down.
Hold the button. All right, feather button is pushed in. And held. What happens if you let go of it?
It just pops out.
Just pops out. And held by the pilot. Why? Because the holding coil, we'll say, will not engage. It will, but it'll just keep disengaging. All right, feathering pump will run. Run and build pressure to over 650 psi. We'll say this extreme pressure will cause a distributor valve to shift and reverse the flow of oil from the pump to prop. So in other words, it reverses whether it's going inboard or outboard. So high pressure oil is then directed to the opposite side of the piston. And unfeathers the prop. And at that point, release the button and the engine goes. Could say that. When prop starts to windmill, release the feather button, and off it goes. All right, that seemed like a lot of writing.
So this prop constantly has oil, it just depends on what side of the piston it's on.
Yep. Constantly has oil. So remember, there's different types. So there's one type that has just engine oil pressure, like on the front, and the governor's either going to add or take away, add or take away. And so you always have the engine oil up on the front. Then there's the double acting, which has engine oil on the front and then governor on the back, and then it's going to switch, so governor is on the front and engine oil is on the back, or it's just draining off unpressurized oil. So you can do both types, but the feathering works in this manner on all types.
Where's that electric pump located?
Physically, Don't know. I've never worked on an aircraft that has this system because you're talking about something that has one of those gigantic Hamilton standards, huge ones. So talking about what, B-17s, B-25s. I never worked on the B series. Well, Beech 18. I didn't work on the Beech 18. So Beech 18 sizing up.
So there's no counterweight here.
Nope. No counterweights at all. All right, so tell you what, we can take a break and watch the video. Yeah, how about that? So when we come back, we'll watch this.